Testing and validation techniques. Hello folks, welcome to the lesson on testing and validation techniques for electrical and electronic systems. This lecture aims to empower you with the knowledge to effectively test and validate various systems, ensuring they meet required standards and function correctly in real-world applications. Testing and validation are crucial steps in the development process, ensuring reliability, safety, and efficiency in electronic systems. Introduction to testing and validation techniques for electrical and electronic systems. What is testing and validation? Testing refers to the process of evaluating a system or its components to determine whether it meets specified requirements. Validation ensures that the final product meets user needs and expectations, confirming that the right software or hardware has been built. Importance of testing and validation. Ensures product quality and customer satisfaction. Identifies defects before deployment, reducing costs associated with post-release issues. Enhances safety by identifying potential risks and addressing them proactively. Types of testing. Unit testing. Focuses on individual components or units of a system to verify their correctness. Performs early in the development process. Example: testing individual circuit board components. Integration testing. Tests combinations of units working together to reveal issues within interfacing components. Ensure modules interact correctly. Example: verifying data communication between microcontrollers and sensors. System testing. Validates the complete and integrated software or hardware system against specified requirements. Focuses on end-to-end system specifications. Example: testing a complete automation system in a factory setting. Acceptance testing. Conducts to determine if the overall system satisfies business requirements and is ready for delivery. Performed by customers. Example: customer testing of an electronic gadget's features. Understanding testing methodologies and validation procedures. Testing methodologies. Black box testing. Tests the functionality without knowing internal code or design. Focuses on user interface, input, and output. White box testing. Requires knowledge of the internal logic of the system. Involves testing algorithms for security vulnerabilities. Gray box testing. Combines black box and white box testing methodologies. Used for higher-level integration testing. Validation procedures. Defining validation criteria. Establishes benchmarks and standards products must meet. Consider functional and non-functional requirements.
Verification versus validation. Verification checks if the product is being built according to the design specifications. Validation checks if the right product has been built to meet user needs. Validation techniques. Review. Examines documentation, architecture designs, code, and requirements. Walkthrough. Informal process where the author presents their work to colleagues for feedback. Inspection. Formal process involving peer review to identify defects. Common tools for testing and validation. Software tools. Simulation software. For example, MATLAB Simulink for testing algorithm performance. Verification tools. For example, Jenkins for continuous integration testing. Hardware tools, oscilloscopes for monitoring waveforms and signal propagation. Multimeters for checking voltage, current, and resistance values. Challenges in testing and validation. Time constraints leading to insufficient testing phases. Complexity in integrating various system components. Dynamic changes in user requirements impacting validation. Best practices for effective testing and validation. Adopt a well-planned testing strategy from the start. Ensure detailed and comprehensive test cases. Leverage automated testing tools for efficiency. Maintain a robust logging and reporting mechanism. Here's a summary: Introduction to testing and validation techniques for electrical and electronic systems. Importance of testing and validation. 1. Ensures system functionality and performance. 2. Identifies and fixes defects and errors. 3. Verifies compliance with specifications and standards. 4. Reduces risk of system failure and downtime. Types of testing. 1. Unit testing. tests individual components or modules. 2. Integration testing tests interactions between components or modules. 3. System testing tests the entire system to ensure functionality and performance. 4. Acceptance testing tests system to ensure it meets user requirements. Testing techniques. 1. Black box testing tests system without knowledge of internal workings. 2. White box testing tests system with knowledge of internal workings. 3. Gray box testing, combination of black box and white box testing. 4. Fault injection testing intentionally introduces faults to test system robustness. Validation techniques. 1. Simulation uses models to simulate system behavior. 2. Prototyping builds physical prototypes to test system functionality. 3. Emulation uses software or hardware to mimic system behavior. 4. Testing with real-world data uses real-world data to test system performance. Testing and validation tools. 1. Multimeters measures electrical parameters like voltage, current, and resistance. 2. Oscilloscopes displays electrical signals and waveforms. 3. Logic analyzers analyzes digital signals and waveforms. 4. Software testing tools automates testing and validation processes. Best practices for testing and validation. 1. Develop a testing plan. Outlines testing objectives, scope, and schedule. 2. Use automated testing tools. Increases testing efficiency and accuracy. 3. Test early and often. Identifies defects and errors early in development. 4. Document testing results. Records testing results for future reference. Here's a summary. What is testing and validation? Testing. 1. Definition: evaluating a system or component to determine whether it satisfies specified requirements. 2. Purpose: identifies defects, errors, and vulnerabilities. 3. Types: unit testing, integration testing, system testing, acceptance testing. Validation. 1. Definition: confirming that a system or component meets user requirements and expectations. 2. Purpose: ensures system functionality, performance, and quality. 3. Types: simulation, prototyping, emulation, testing with real-world data. Key differences. 1. Testing focuses on defects, while validation focuses on requirements. 2. Testing is typically done by developers, while validation involves users and stakeholders. Importance of testing and validation. 1. Ensures system quality and reliability. 2. Reduces risk of system failure and downtime. 3. Improves user satisfaction and confidence. 4. Saves time and resources by identifying defects early. Benefits of testing and validation. 1. Improved system performance and functionality. 2. Enhanced user experience and satisfaction. 3. Increased system reliability and uptime. 4. Reduced maintenance and support costs. Here's a summary. Importance of testing and validation. Ensures system quality and reliability. 1. Identifies defects and errors early. 2. Verifies system functionality and performance. 3. Reduces risk of system failure and downtime. Saves time and resources. 1. Early defect detection reduces rework and repair costs. 2. Minimizes maintenance and support costs. 3. Optimizes system development and deployment. Improves user satisfaction and confidence. 1. Ensures the system meets user requirements and expectations. 2. Provides reliable and consistent system performance. 3. Enhances user experience and trust. Reduces risk and liability. 1. Identifies potential security vulnerabilities. 2. Verifies compliance with regulations and standards. 3. Minimizes risk of system failure and associated liabilities. Enhances system security. 1. Identifies potential security threats. 2. Verifies system defenses and protections. 3. ensures secure data handling and storage, supports continuous improvement. 1. Provides feedback for system improvement. 2. Identifies areas for optimization and refinement. 3. Enables data-driven decision-making. Increases system uptime and availability. 1. Reduces downtime and maintenance windows. 2. Ensures system reliability and consistency. 3. Optimizes system performance and throughput. Conclusion: understanding testing and validation is vital for developing reliable and effective electrical and electronic systems. By implementing the discussed methodologies and techniques, you can enhance the quality and reliability of the systems you develop. Thank you for taking this lesson on testing and validation techniques. We hope to see you in the next lesson. Happy testing!